We expect the James Webb Space Telescope, JWST, to make great discoveries. Mankind has always been curious about the mysteries of the universe. Since its mission began in 2021, JWST has been quietly peering deep into space and capturing images that will change the way we see our place in space. Recently, Webb made an amazing discovery. This strange observation breaks the laws of physics and messes up our understanding of reality, worrying scientists. Are we alone in the universe, or are there hidden forces waiting to be revealed? Join us as we explore JWST's recent discovery. Dark matter is like the hidden secret of the universe. There's this mysterious thing that we can't see directly, but we know it's there because it pulls things together with its gravity. It is like a cosmic ghost that circles and affects everything around it. Scientists believe that it makes up a huge part of the universe, about 25%, which is a big deal if we can't even see it. All this dark matter has long puzzled scientists, ever since Fritz Zwicky first proposed its existence in 1933. It's strange because even though it's everywhere, we can't catch it. It's like trying to catch a shadow. Scientists thought for a while that the universe was slowing down, but then along came NASA's Hubble Space Telescope, which looked deep into space and discovered something amazing. The universe is speeding up. About 95% of the universe consists of invisible twins called dark matter and dark energy. They are like the behind-the-scenes company of the universe, doing all the heavy lifting when the stars are in the spotlight. Now we have this great new device called the James Webb Space Telescope, JWST, and it's like the superhero of space instruments. It has this massive mirror and can zoom in on things that are far away. For dark matter scientists, it's like hitting the jackpot in a cosmic casino. JWST can do this cool trick called gravitational lensing. Imagine you are looking at a distant galaxy, but there is a closer galaxy in between that bends the light from the distant galaxy. By measuring how much light is bent, scientists can determine how much dark matter hangs around a nearby galaxy. Some smart people in Italy are using JWST to study galaxies further back, like 13 billion years ago. They also use highly sophisticated computer simulations to understand how the first galaxies formed. There are different ideas about what dark matter is made of. Most people think this cold matter is only affected by gravity, but some think it could be hotter because the small pieces are moving faster. It's like the difference between ice cubes and hot cocoa. The world's largest radio telescope, currently under development, sees great potential in such efforts, believing that by breaking the fundamental limits of physics, we can ultimately improve our daily lives. But that's not all. Scientists have another interesting argument. When we look into the visible universe, which includes the Earth, Sun, stars, and galaxies, we see things made of protons, neutrons, and electrons, the building blocks of atoms. However, a shocking revelation in the 20th century says that ordinary matter, also known as baryonic matter, makes up less than 5% of the mass of the universe. The rest appears to be made up of some kind of dark matter and another mysterious force known as dark energy that seems to push things apart and defy gravity. This realization opens up a whole new realm of questions and possibilities in our quest to understand the cosmos. Most scientists are still trying to see dark matter directly. This matter does not interact with normal matter and is invisible to light and other radiation, so we cannot detect it with our current tools. But we believe it exists because it seems to affect the motion of galaxies and galaxy groups due to its gravity. Consider a rotating spiral galaxy. Stars near the center, where most of the galaxy's matter resides, should be moving faster than stars further away, but as we look, they are all moving at about the same speed. That is strange. It makes sense if we imagine that there is this invisible mass of dark matter around the galaxy that pulls the stars with its gravity. Some scientists believe that to fully understand this, we may need to rethink how gravity works. Now to dark energy, which is even stranger. When scientists first discovered it, they were surprised. They thought gravity was slowing the expansion of the universe over time, but when they measured it, they found it was accelerating. It's like throwing keys in the air and expecting them to fall back, but instead they shoot up to the ceiling. Scientists now believe that this acceleration is due to something called quantum fluctuations in space. These fluctuations create a kind of thrust that causes the universe to expand faster and faster over time. Some believe that it is consistent with an idea that Albert Einstein called the cosmological constant. He thought that this constant could act as a force that pushes against gravity and prevents the universe from collapsing, but he abandoned the idea when he realized that the universe is expanding. Now, with the advent of dark energy, scientists are revisiting this idea, trying to understand why this mysterious force exists and what it means for the fate of the universe. In Berlin in 1915, amidst the turmoil of the First World War, Albert Einstein proposed a pioneering theory of gravity known as general relativity, which replaced the long-held ideas of Isaac Newton. By 1960, Einstein had applied this new theory to the most massive object he could think of, the universe itself. His calculations led to a remarkable conclusion. The universe could not stand still. It had to either expand or shrink. This idea remained theoretical until 1929, when American astronomer Edwin Hubble made a revolutionary observation. He noticed that the galaxies were dispersing as if caused by a huge explosion. This discovery was later seen as a sign of the Big Bang, the moment when the universe began to expand. Essentially, Hubble observed that the space between galaxies was expanding, suggesting that the universe itself was expanding. Einstein's theory includes various models of the universe. One possibility is that the universe extends infinitely without boundaries. Another possibility is that it curves back on itself like the surface of a higher dimensional sphere, creating a finite but infinite universe. In the latter scenario, if we had powerful enough telescopes, we could theoretically see the same galaxies on opposite sides of the universe. Some scientists argue that the universe has an advantage, not in a physical sense, but in terms of time and visibility. They point out that the universe began with the Big Bang about 13.8 billion years ago. The question in modern astronomy is whether JWST can see the edge of the universe. JWST, with its advanced technology, is designed to look deeper into space and longer than any previous telescope. It can detect the weakest and oldest light in the universe, and possibly detect objects that existed only a few 100 million years after the Big Bang.
Although it cannot see the absolute edge of the universe because the edge is constantly moving as the universe expands, it helps us understand more about the formation and evolution of the early universe. When you think you could spend $1 billion on a space telescope, it's natural to wonder if it can really see that far into space. JWST is 100 times more powerful than the famous Hubble Space Telescope. This advanced telescope can capture very faint infrared light from the first galaxies in the universe. It is also designed to study other planets orbiting stars in our galaxy and check for signs of life in their atmospheres. However, it remains uncertain what scientists will find when they point the telescope to the edge of the universe. To understand this, we need to know the observable universe and the unobservable universe. The observable universe includes everything we can see or detect with any kind of radiation, but detection has its limits. The most distant light we can see comes from the cosmic microwave background, which formed about 13.8 billion years ago. At that time, the universe was like a thick fog, making it opaque. Some scientists believe that gravitational waves and neutrinos, which are tiny particles, may originate even further away. But we can't confirm this yet, because we don't have the necessary technology. Cosmologists who study the universe say that the observable universe is only a small part of a much larger reality point. One of the most distant galaxies discovered by scientists is Abell 2744Y1. This galaxy is important for several reasons. It is so far away that its light takes 13 billion years to reach us. Since the universe is estimated to be 13.8 billion years old, this means that we are seeing Abell 2744Y1 as it was when the universe was still very young, about 650 million years old. This happens to all distant objects in space because the light from those distant objects has traveled such a long distance to reach us. The discovery of Abell 2744Y1 involved 3 different telescopes: Spitzer, Chandra, and Hubble. All these telescopes operate on different parts of the electromagnetic spectrum. Spitzer uses infrared light, Hubble uses visible and near-infrared light, and Chandra collects data using X-rays. This combination allows scientists to study the life cycles of massive stars that culminate in supernovae, with a special focus on superluminous supernovae such as DES 16C2NM. These events are key to the cosmic cycle of matter and energy, producing vast amounts of energy and breaking down the materials that later form stars and planets. Discovered by the Dark Energy Survey, DES 16C2NM provides insight into ultraluminous supernovae that emit significant ultraviolet light, crucial to understanding their dynamics and the conditions that lead to powerful explosions. Additionally, the recent JWST findings challenge existing models of galaxy formation, suggesting a universe that may have formed from a massive black hole in another connected universe.